Hello and welcome to the second part, or the second video in lesson 15. Before I go through and do this example, throughout Unit 3 you are going to be using Google Sheets consistently, so you have laptops available to you, and I want you to get comfortable with Google Sheets. And when I do these examples with spreadsheets, if you go to the Google Classroom, so whether you're 4UB or 4UA, doesn't matter which one, if you go into that classroom and you scroll down to Unit 3 Journal 1, because you'll see that all the journals are electronic as well, so you can, you're going to be submitting them electronically anyway. In that first journal, I've got all of the examples typed in and ready to go for you. So as you're watching the video, you can just simply pull this up, the example's right there, and you can practice punching in the commands. So if you're to open number 15, you're going to get that first example from the smartboard file here. It's already been entered for you, and I want you to get used to practicing that. Now that column isn't there at the moment, so what I did was I wanted to add a column on the left side. So for this question, I entered the data, I went here and I said insert one column on the left. So it gave me an extra column, because what I want to do is I want to go down here and I'm going to type in my three measures of spread: mean, median, and mode. All right, because that's what the question A is asking us here. So we have two classes that wrote the exact same exam. We want to determine the following. We want to find the measures of central tendency for both classes. And once you get the data entered in, the spreadsheet makes it so much easier. So to find mean, I'm going to find the mean of both classes. So you put equal sign, and that brings up all the commands, or allows you to punch in all the commands that are available in Google Sheets. Now, most spreadsheets use average. They don't have a mean function. If I type in mean, there's no function there. So it gives you suggestions, but mean, they use average, and they have definitions there. So if you look at average, it tells you exactly what it's doing. So we want average, and then you highlight what you want the average of. So I want the average of that data. I hit enter, and there, it calculated average for me, just like that. Same thing here. I want to find the average of this class. Click average, select the data that I want, enter, and now I have the means of both classes. All right, and we might as well do the rest of them. If you type in median, MED, there's only one command, so it's easy to pick from. Oops, and I did it wrong. I scrolled. Median, select the data, hit enter, and now it finds the median equals median, bracket, scroll up, hit enter. So it calculates the median, and it will calculate the mode. So equals mode, and I just select the data that I want, enter, equals mode, and again I can select the data I want, just like that. So now I have calculated mean, median, and mode for all the data, just like that with the spreadsheet. I'm going to copy that, and you can copy it at any point in time and put it into a Google Doc if you're submitting a report to me or you want to include some data. It works really smooth. Takes a little bit more time with the smartboard software. It looks a little bit funkier, but that's all right. So there we go. There is our answer for number A. So now I'm just going to move over to the smartboard. And at the smartboard, I'm going to answer a couple of the questions here. So this is the answer number A, and then just labeling it Class A, Class B. So B part. Using your results from A, compare the two classes. Well, we have three measures here. We got mean, median, and mode. Which of those three is the correct one, or the one that best lets us do that comparison? And the answer to that is median. The answer to that's median. And the reason for that, and I'm going to put the reason first here, for small data sets, median is the best measure. And I'll talk about the why in 1 second. All right, I'll leave that for part C. All right, and you're asking me what would you consider a large data set? What would you consider a small? I would say rule of thumb at this point in time, I would say 100. If you have less than 100 pieces of data, I'd be using median. If you go over the 100 mark, mean is probably fairly safe. Now that's not a hard and fast rule, but it's a general rule of thumb that you can kind of follow as you go through the data available. All right, so to answer the question, then if we use the median, we can conclude that both classes have a similar level of achievement, level of academic achievement, and we'll say in the low 70s. All right, so that tells me that the classes are similar, okay? And I know I wrote that twice, but that's what that really tells me. So I'm looking at this as a teacher, because if you look, there's many more. If we go back to the spreadsheet, if you compare, I have a lot more, oops, wrong way. Okay, there's a lot more in Class B than Class A, and you always think that a smaller class will always produce higher marks perhaps, but it's not necessarily true. And here it tells me that actually Class B is achieving a hair more, but I mean, you're splitting hairs on 2%. So we can say that, yeah, we're pretty even here. But if you look at the data down the column here in Class B, look at the spread. Because in Class A, we have 71, 71, 71. Very, very consistent in terms of the three measures. But in Class B, we have 67, 73, and 80. So let's take a step back for a second. I'm going to go back to the keyboard and go back to that spreadsheet. And we're going to identify outliers. Okay, so I'm answering question C now, looking at outliers. So when I go back to the data, look down Class B. What marks stick out? So if I go down here, 12%. That really sticks out because 12% is a mark of a student that perhaps has dropped the course and the teacher hasn't removed the data, or maybe it's a student that is, gone on medical leave or something significant has happened. So 12% is way outside the what we would consider a normal mark for a student making an effort. Scrolling down further, just to make sure there's no other ones. Oh, 15%. There's another one that kind of sticks out. Not really something you would expect to see in a class. That looks like it. So we have two outliers here. All right. So I'm just going to type that in so I remember. Outlier, and I'll just put a 12 in case I want that data back. Because what I'm going to do is I'm going to delete it because I want to know what effect does this have, okay, on my data. So I'm going to go ahead. I'm just going to hit delete. Delete. I got rid of the outliers. And look at the difference here. So I'm just going to bring that into the smartboard file, copy and paste it, shrink it down a little bit, and put it underneath for C. And look at the difference. Specifically, look at the difference in the mean. Look how that average has changed quite significantly. So if we look at 67 versus 71, we see that it's a little bit better. The overall mark, or the overall comparison between the three, but we can see that the mean has significantly changed. So in C part, what's the effect of any outlier on the mean or median? So outliers, and I'm telling you what the conclusion is. It's tough when you're only seeing one example, but if we look at specifically median, 73 to 73.5, I would say that's a fairly small change. So outliers have a small effect. A or E, I don't know. I'm not an English teacher. There we go. Effect on median. But look at the difference that removing 2 marks. All we did was remove 2 marks, and we went from a 67 up to a 71. So outliers greatly affect the mean. Now, when you get into huge amounts of data, so let's say I had the marks of 1,000 students, and I took those 2 marks away, probably wouldn't have much effect on the mean. But when we're talking down a class of 30, 25, 2 students greatly affect the mean. So that's why when you look on, if you look at your midterm report or your final report from last semester, you'll see that we report the median when we report the class, we don't report class average, it's the median, it's the middle mark, because if you have those outliers, it doesn't influence the class, what the class is performing at. All right, so there is your, that example complete. Just going to go back, switch back to the computer for a sec here. So if we move into the next slide here, I've got a couple of, just a summary here. So for mean versus median, just what we talked about, putting it in actual note form here. For large sets of data, mean is better. And like I said, right now, I'm going to say that we're talking, you know, plus 100. All right. For small data sets, median is better. Okay, so you got to decide when you're looking at some of the research that you're doing, or if you're working on homework, you got to ask yourself, how big is this data set? Mode. Now mode we didn't talk about at all in that example, but we did calculate it. Mode tends to be only significant for large groups of data. Very large. So for the example of class marks that we just did, way too small. And even for class marks, I would never ever use mode, even if I had, you know, all of the students in Canada. It's still not a measure that is overly useful. When's mode used? A good example is when stores are stocking their inventory. So if you go into a shoe place, a shoe company, you probably, if you're a size 9 to 11, you probably rarely have a problem getting a shoe. Okay, it's always in stock because the vast majority of our population is between 9 and 11. I'm talking men's. Ladies, I'm not sure what the equivalent is, but for men, 9 to 11. If you are, you know, like my brother who's size 13, 14, it's kind of a hit and miss because they don't stock a lot of 13, 14s because they know that there is not a large amount of the population that requires that. Maybe on the other side, a little bit better because they're maybe thinking more towards the children, but the majority, when shoe stores are looking at their stock, they are making sure they have a large quantity of the 9 to 11. So that's what the mode is looking at. Mode's looking at what's the most consistent thing here. And then you'll see it with dress sizes, pant sizes. You'll go in and you'll see a huge number of, 36 to 38 waist pants for men. And that's just because that's where the average population falls. Weighted mean's the next topic here. So weighted mean. What this allows people to do is provide to give specific items more importance when they're calculating, doing some statistical analysis here. So the best way to explain it is just to show you the next example here. So we're looking at, again, an English teacher's mark book, and they handed out an essay, newspaper article, a Shakespeare project, really big essay, and then a content test in the same unit. Now going down, the teacher knows that the newspaper article, for example, is not really as important or has as much value as the essay. So what they do is they provide weightings. So there's your weight. So if the newspaper article is the baseline, it's worth 1. The first Little English essay is worth 2 newspaper articles. The Shakespeare project's worth 2 newspaper articles. The big essay is worth 5 newspaper articles, and the content test is worth 4. So it gives it what we call weight. Okay. So rather than kind of switch halfway through, I'm going to do this next video. I'll do this, finish up this example, and hopefully the next one, and then you have a start, and I can help you with the Google Sheets. So I'll be back in a sec.